Thank you. Thank you for coming.
Stand by the mic.
Oh, see, that's all right. Yeah. Thank you for coming to this talk, and thank you for giving me the opportunity to be here. My name is Youngmi Park, and I'm working for EMB EBI as a software engineer. Today, I'm going to talk about EBI Search as a service. Before starting the presentation, I would like to thank to my team, web production team in EMB EBI. This is the outline of the presentation. So I'm going to start with a brief introduction about EMB EBI. After that, I will move to EBI Search, web interface, RESTful web services, and then the collaboration works we've done with other teams. After that, I will demonstrate some simple examples working with EBI Search APIs. EMB EBI is a part of European Molecular Biology Laboratory. Unlike other outstations of EMB, we don't have one lab. We mainly focus on bioinformatics. So we provide freely available up-to-date biological data and bioinformatics services. So using the services, users can share data, perform complex queries, and analyze data in various ways. We do computational biology researches, so we also provide bioinformatics training courses, online and offline. Also, we are working with the industrial people on as Alexia node. We also contribute to the coordination of biological data provision through Europe. And now I'm going to move to the main topic, EBI Search. EBI Search is a full-text search engine allowing users to access all available data in EMB EBI. So now we have more than 100 data sets. So for example, protein sequences, nucleotide sequences, gene expression, protein family, protein interactions, macromolecular structure, small molecular ontologies, some patent and literature, and so on. So basically, early morning, we check individual data sets. And if we find updated data set, we index them from scratch. So our users can get up-to-date search results from us. We provide the network of cross-references so users can easily navigate across multiple resources. And we provide, name suggested, we provide search functionality and also other useful features through the RESTful interface. So our API users can integrate these features into their project. Here you can see some statistics about EBI Search. So as I mentioned, now we have more than 100 data sets, and from them we indexed more than 1.5 billion biological entries. And last year we processed more than 282 million requests from about 310,000 unique hosts. And we provide these features through the web interface. So as I mentioned, we have a vast amount of data. So we provide filters and process to help users to narrow down such results. And as I mentioned, we provide cross-reference networks so for easy navigation. Also, if you type something into a search box, you get some suggestions like identifiers of database or maybe title of publication, ontology names, so on. And if you want, you can save your search result for your further analysis. Also, you can launch biological tools with your result. So we provide RSS feed on the result pages. So if you need to get notified of any updates of such result, you can use RSS feed. Maybe, for example, latest publication about a specific topic, something like that. The EBI Search web interface is implemented using EBI Search RESTful web services and Angular JavaScript framework. So, which means that we are the provider of the EBI Search as a service capability, but at the same time, we are one of the consumers of the capability. This is the web interface. As you see, there is a big search box on the top, and below that, there is a search result. On the left side, as I mentioned, we provide buses and filters, so you can narrow down to a specific knowledge domain. In the main section, you can find a list of entries found, and each entry has a metadata and a list of cross-reference links. So clicking on the cross-reference links, you can jump to other resources and find the relevant information. And as I mentioned, you can save your result in a various formats, such as XML, JSON, CSV, CSV, or simply a list of identifiers or session numbers, so you can use it directly as an input to other pipelines. And depending on which data set your search result comes from, you can launch biological tools with your result. So in case of Unipro data, you can launch BLAST sequence search or cluster omega tool. And as I mentioned, there is a RSS feed feature. Now I'm going to move to the RESTful interface, which plays the main role for the EBI search as a service capability. And these features are available through the RESTful API, so obviously search, so you can perform search with without facets. We provide the cross-reference searching API, so you can build your own cross-reference network using them. Autocomplete is one of the common features available in modern search engine. And top terms API is to return a list of popular terms from a specific field. So it's good to get hint of data characteristic of the field. And then we have more like this API. It's a bit advanced one, but basically it tries to find the similar entries to a particular entry. We provide an interactive documentation about the APIs based on OpenAPI specification. And if you visit the documentation, you can also find the links to download the sample clients, which are working with the RESTful API, which are written in Java, Python, and Perl. This is the documentation about APIs, and the APIs are grouped into a feature category. And here you can find all information you need to know when you use EBI Search API. And at the same time, you can also make a test code from there and then see the result on the web interface. This is a description of a particular API. So as you see, there are descriptions about API, HTTP method, and URL template. And there's a list of response formats. And there's a table which contains a list of parameters working for the API. And each parameter has a name, description, and data type information. And also each parameter has an input box. So if you type something into the box, and then you can't see here, but at the end of this page, you can find the send button. So if you click on the send button, the request will trigger, and then you can see the result here on the same page. And if you land on this page the first time, you may have no idea what kind of values you need to type into parameter input boxes. So we provide some examples. So for this API, we provide the examples of how to perform search, how to do pagination, or how to apply different sorting criteria. So if you click on any of them, the relevant parameter input boxes are filled with the example values. So you just need to click on the send button, and you can see the result after that. This is an example of request output. There are several sections. So as you see, you can learn how to make a call with the call command line. There is a HTTP, there is a request URL, so you can copy the URL and then play with other type of RESTful client or simply a browser. And you can see response body, HTTP status code, and HTTP response headers as well. So far, I talked about what kind of features are available through the REST API and how to use the documentation. And these projects are using the EBI search as your service capability. And I'm going to show some of examples here. This is RNA Central web interface. RNA Central is providing a comprehensive and up-to-date non-coding RNA sequences. And if you are interested in this project, you can find more details in the poster sections. There's a poster about RNA Central. And how we work together is that they produce the metadata of their actual data, and then we index their metadata, and the RNA Central team use our API to implement the search result page. So as you see, there's a big search box. If you type something, you get some suggestions which are coming from EBI Search Autocomplete API. And below that, there's a process and the result. These are coming from Search API. This is another example, Hammer website. Hammer is one of the popular sequence analysis tools, and they provide the web interface for users to try sequence similarity search on the web interface. And this is an example of a P-Hammer search result. And if you enable to show cross-reference sections in result table, you can see a list of beautiful icons per entry. And each icon indicates a different biological meaning. And if you move your mouse cursor over the icon, you can see the actual cross-reference links belonging to the category. So this cross-reference section is working with EBI Search cross-reference searching API. This is Omics DI web interface. Omics DI is a centric framework for heterogeneous omics data. This is their main web page. They presented nice visualizations here. And this is quite useful for users to get insight of their data. And these visualizations are fed with data coming from EBI Search APIs. Also, Omics DI team uses our Search API for their search result page. And the more like this API is the actual outcome of a collaboration work we've done with the Omics DI team. Now I'm going to demonstrate some simple code working with EBI Search APIs. This is a simple search result page written with jQuery JavaScript framework. So I will show. So I selected a data set, and then I checked whether I want to see the cross-reference links as well. So as you see, there's a search box. Then I triggered search request and then get back the result. So this simple application can be written with your favorite language and using EBI Search API without setting up indexing or search infrastructure. This is another example working with cross-reference APIs. So basically, how it works is that starting from a specific entry, I'm using some cross-reference between two data sets. And using the cross-references, I'm building the network of cross-reference. Yeah. I started from a specific Uniprot entry, and whenever I click the circle, it triggers to find cross-reference, and then if there is a cross-references, I expanded the network. So as you see, without setting up complicated system, you can simply find some hidden information from the data available in EMBI EBI search engine. Talk is almost over. So here I put some useful links. The first one is EBI Search main web interface. The second one is the public GitHub repository where you can download the sample code I demonstrated in previous slide. And then there's a third one is the RESTful API documentation. And then the last, we have a user support form. So if you have any questions or suggestions, or if you find any bug, you can find us through the support form. Thank you for listening. Yeah, thank you for attention.
Thank you very much, Young-Mi. Are there any questions, comments, thoughts, observations?
Thanks for a very nice overview. I'm just wondering, I have very particular interest in open targets. So I'm just wondering, EBI search also cover all the open target resource, or I just wondering what's the connection between two?
We don't index data directly from open target project, but I'm not sure which data is working with open target project particularly. But if I know, probably we can find some, or yeah. But at the moment we don't get the data directly from open target project. Yeah.
Yeah, just one quick question. Search result downloadable. So say if I search get the result, like you show the network with the interaction partner, may I download it?
Yeah, of course. Yeah, of course. Yes, text form. Yes, probably. Yes. Yeah, I will talk later. Yeah.
Okay, and just one other comment on open targets is anybody can use open targets. It's freely available for use. So do encourage people to go to the web page, try it out, and have a look at it. And it's a great platform for integration of lots of information about diseases, targets. So thank you very much indeed.